In today's lecture, we will see a new technique for solving nonlinear equation, and the name of this method is secant method. Okay, it is known as secant method. So we will see in detail about the secant method. Okay, so secant method is actually it is a modification of Newton's method. Okay, it is the modification of Newton's method. So what is the problem with the Newton method? In Newton method, as you have seen in the last lecture, that xi plus 1 is given by xi minus f of xi divided by f dash xi. So you need the first order derivative, right? The first order derivative in Newton's method, right? You need first order derivatives in Newton's method, right? So you have to feed this equation also. So if you are trying to solve this by solving a nonlinear equation by using Newton's method, then you have to feed what is the derivative of that function. So sometimes it is difficult to find the derivative of some functions. For example, let us consider a function. F of x is equal to sine square of tan of cosine inverse x. So this kind of function, if you are going to solve, this is a highly nonlinear function, and you need to find the derivative. So maybe sometimes it will be very hard to find the derivative. So in these cases, actually the Newton method is something we can feel it is difficult. Now, in order to avoid this, we are going to replace this f dash of xi. Okay, in the Newton's method, this f dash of xi is coming in Newton's method. Okay, in Newton's method, f dash of xi is coming. So we are going to replace this term. Okay, and that method is known as regular Farsi. So what we are going to do, we replace f dash of xi with that is f dash of xi. Now we will change with f of xi minus f of xi minus 1 divided by xi minus 1. That means if you have a function like this, and this is your xi minus 1, and suppose this is you have a function like this. Okay, you have a function, this is f of xi, this is xi minus 1, that is f of xi minus 1, this is xi minus 1, and this is xi, and this is f of xi. Now actually you want to find the slope at xi. Whenever you are considering the Newton's method, you are going to find the slope at xi, and it will be finding the meeting position. So this is what happening in Newton's method. Okay, that is what happening in Newton's method. But what you are going to do here, you can see here, this f dash means actually the slope, right? What do you mean by slope? Slope is delta y over delta x. So you can see that here this is your y, so the change in y, so this is your yi, and this is your this is your yi, and this is your yi minus 1. So delta y means delta y is nothing but yi minus 1. Am I correct? So, and delta x is nothing but xi minus 1. So you are drawing a line. Actually you are finding the slope here, you are drawing a line. So I think you have already seen this kind of thing. That means you are drawing a line here, and you will be proceeding further. So I will explain in the next slide anyway in detail. So you can see that you are drawing a line, and this kind of line, that means whenever you draw a line on a curve which meets 2 points in the curve, that is known as secant. Okay, suppose you are having a circle and you draw a line, and this is a secant actually. And if you have a curve like this and you draw a line, you can see that it is meeting at 2 points. So these kind of things we will call as secant. Okay, secant. You know, in Newton method actually we draw the tangent. Okay, so in Newton method whatever you are seeing here, that is the tangent. Okay, so we will replace actually the tangent with the secant. Okay, now we will see how we are getting the solution in this method. Okay, so let us consider a function. Let us consider a function something like this. Okay, and you will start with some initial brackets that we have, because we have already seen that these are all bracketing methods, that is the solution will be between some 2 points, right? So this is x0 and this is x1, and you can see that this is f of x0 and this is f of x1. Now in Newton's method actually you will start with 1 point. For example, you may start with x0 or you can start with x1, but now this is the method. Now in this method you will not be starting with x0 or x1, you will be starting by drawing a line which is joining the x0 and x1. Okay, so I am going to draw a line, right? Whenever I draw a line, you know it is meeting at some point in the x-axis, so we will be finding this new value as x2, and this is f of x2. Now you will be thinking that you have heard this kind of thing before, that is you have seen something known as the regular falsy method, right? So you have already seen regular falsy method. So in regular falsy method you will be finding the new value x2 in the same way. However, in the regular falsy method, suppose you can see that here you are having 2 intervals, right? This is the interval 1 and this is interval 2. Now you can see that the function is negative here, and the function for x1 it is positive here, and for this x2 also positive. So in regular falsy method, what you will do? You will be selecting 1 or 2. In the above case, you will select you see here this is negative, and this is positive, so you will select interval 1, right? But there is nothing like that in secant method. So in secant method you will not be caring about the interval. Okay, so here you will not be caring about interval, so you will not see the interval, which interval you have to select in secant method. So in secant method you will not, we can say you will not care about the interval. Okay, so what you will care? So at first you will find x0, after that you will find x1, x1 and x0 and x1 will be given. By using this you will be finding x2. After that you will consider the interval x1 and x2. By using x1 and x2 you will find x3, and by using x2 and x3 you will find x4, and by using x3 and x4 you will find x5, and so on. Okay, now we will see what is happening. Now we know what is x0 and what is x1, and we know what is f of x1. Now we will draw another secant between f of x2 and f of x1. So what you are going to do? Now you see we are going to draw another secant. Okay, I'm going to draw another secant. You can see this is the point and this is the point. I'm going to draw another secant. You can see it is going and it is meeting at the point x3. Okay, so at first we have x0, then we have got x1, then we got x2, now you got x3. Now at x3 we will find f of x3. Now we will draw the line between, x3 and x2. So you can see you are going to draw the line between x3 and x2, right? So whenever you draw the line between x3 and x2, you will get x4 and you will find something known as f of x4. After that you will draw the line between x3 and x4. So if you draw the lines, it's difficult to drawing. It is difficult for me to draw this line. Anyway, you can see that we have drawn a line between x3 and first we have drawn line between x0 and x1, f of x0 and x1. After that we find the x-intercept, then we find x2, after that we find x3, and so on. And you can see that the initial solution was somewhere at x2 and it moves to x3. After that it moves from x3 to x4. Now you can see that it will be closely approaching the solution and finally you will get the solution. So this method is known as secant method. Now we will see a problem by using secant method. Okay, so let me find a problem for secant method. So solve, this is the question, solve x raised to 3 minus 8x minus 5 equal to 0. Okay, so we are going to find the solution. So what is the method to find the solution? So we have seen the method to find the solution. At first it is given, we are going to find where does the solution exist. Okay, so at first of all we will assume x is equal to 0, then we will find f of x, that is equal to when x is equal to 0 will be, okay, we can take some values, so let us assume that given that the solution is between, the solution is between 3 and 3.5, is between 3 and 3.5. If this is not given, what you will do? If this is not given, what you will do? So you can take actually arbitrarily any point or not. Is it possible? So if this is not given, you have to find f of 0, f of 1, f of 2, like this, and finally you can get the interval. Okay, if you don't know the interval, finally you can get the interval by substituting values for x. Okay, for x is equal to 0, x is equal to 1, x is equal to 2. So if you are getting a positive, negative, for example f of 1 equal to positive and f of 2 is equal to negative, then you can see that there is a sign change, so the solution will be between 1 and 2. Even though if it is not given, it is possible to find the solution. Okay, now we will see, let us assume that the initial approximations are 3 and 3.5. That means x0 is 3 and x1 is equal to 3.5. Now when you know x0 and x1, you will find x2. Then after finding x2, you will use x2 and you will use x1 and x2 to find x3. Then you will find x2 and x3 to obtain x4. Okay, so this is the procedure. So for that we will be drawing the columns. So at first we have number of iteration, and then x0, then f of x0, then x1, f of x1. After that we will, by using x0 and x1, we will find x2, and also we will find f of x2, and also you can find the relative error. Okay, that is up to you. Anyway, for the iteration 1 we have x0 is equal to 3 and x1 is equal to 3.5, right? So we will find what is f of x0. F of x0 you will get it as -2, and f of x1 you will get it as 9.875, right? Now by using the formula, that means that is the formula f dash of xi, we will be replacing with f of xi minus xi minus 1 by xi minus xi minus 1. So we will be having the formula like this, right? So our xi plus 1 is equal to xi minus f of xi by f dash of xi, and this formula was for Newton-Raphson method. So we will replace this f dash xi with something else. Am I correct? So what you are going to replace? You can see we will take this equation. We will take this equation to replace f dash of xi. So by substituting this, it is f of xi minus f of xi minus 1 whole divided by, so it will come in the numerator, xi minus 1. See? So we will be getting this. So by using this equation we will calculate x2 by using this equation. Okay, now how to get x2 by using, because you know x0, you have x1, so how to find x2? So x2 is nothing but x2 is equal to x1 minus f of x1 into x1 minus x0 divided by f of x1 minus f of x0. Am I correct? Yes. So f of x1 into, yes, okay, that is correct. Now you can see, you can find x2, and x2 is 3.08421, right? Then you can find f of x2, you will get, because after finding f2 you can put it in our equation, because you know f of x is you know this f of x is equal to how much? F of x is equal to x cube minus 8x minus 5, right? This is your f of x. Yes, f of x is equal to x cube minus 8x minus 5. Now f of x2 you will be getting as 0.33558. okay, this error we will not find it now. Anyway, inshallah I will tell you how to find the error. Okay, next, in the next iteration, what we are going to do? So the second iteration, we got our x1. Now we will replace our x1 with our new value. Now we will use x1 and x2 to find x3. So this we will put it here, 3.5, and this value we will put it here in the place of x1. That means 3.08421, right? 3.08421. So by using this, now you know f of 3.5 is already we have calculated 9.875, and f of 3.08 is also calculated. It is minus 0.3358. Okay, now we will calculate our new value x2 by using above equation, and x2 will be 3.09788. okay, and f of x2 is minus 0.05320. Now we will use the third iteration. In the third iteration, we will change again our x0 with x1, 3.08421, and we will use our x2 as new x1 as our new x2 as our x1, 788. okay, after that, you know f of x0, that means f of 3.08 is minus 0.3358, right? And when you know x1, that means f of 3.09 is minus 0.0520. So you will be finding new x2. You will be getting x2 as 3.10045. okay, and if you calculate f of x2, you will be getting it as 0.00039. okay, what you can observe here, can you tell me? So what you can observe here? You can see that initially the error was 0.3. now the error become 0.05, 1 by 10th almost of the previous value. Now it become 1 by 1000 of the initial value. So you can see here, not the error, actually the function value. The function value was 0.033. that is, the function value is now reducing, right? Whenever it becomes 0, the value that you're going to get, it is the value of the x2 that you are going to get is the solution, isn't it? Now this is for the fourth iteration. You can see for the fourth iteration you will use this 3.09978. then you will use this new x2 as x1, 3.10045. okay, now you know what is the f of 3.0. f of 3.097 is minus 0.05320, and this is 0.00039. and by using x0 and x1, you can calculate x2, new x2 as 3.10043. and if you are going to find the solution, it is, if you are going to find the f of x2, the new value, you will get exactly 0. okay, now let us continue this again to understand what is the, so let us consider fifth iteration. Now your x1, 3.10045, and your x2 as new x1, 3.10043. now you know what is the function value, 0.00039, and this value, this is 0. you can see that you will again get the same thing, 3.10043, because f of x1 is 0. so if you are substituting here, so f of x1 become 0 means x2, your new x2 will be equal to x1. That means the solution you have got. So whenever the function value becomes 0, it is nothing but the solution. So the solution is here itself, you have got the solution. Again, we are getting the solution. Now if you repeat it again, it will not change because the function value has reached 0, right? So this is known as the secant method. Now how to find the error here? To find the error, you have to that is the convergence rate. Actually, this is not the error, actually the convergence. To find the convergence, you have to take the new x2 3.09788 minus 3.08421 divided by the new value 3.9788. okay, so anyway, that is not required, so I am removing it. Okay, so this is known as the secant method. So this is one of the fastest method, you can see, but the main advantage is it do not require any derivative, right? If you have a function, you can easily program this by using the computer. Okay, so this is known as the secant method. Now I hope that this is clear to you. Now we will see another kind of method which is known as the successive approximation technique. However, I will not be asking this for the exam, but I will give you an idea of this successive approximation technique, okay, because you have a lot of methods to study, so I will not be asking this for the exam. So the successive approximation technique, successive approximation technique, okay, this is not successive approximation technique. So we will be writing, suppose if you are having a function f of x, we will be rewriting this function, rewriting the function f of x as x is equal to some other function of x. Okay, so I will tell you what is this procedure. So let us assume that there is a function f of x. Assume that there is a function f of x which is given by x cube minus 2x minus 3. Now at its root we have f of x equal to 0, right? That means x cube minus 2x minus 3 will be equal to 0. So we can write our x cube is equal to 2x plus 3. So x is equal to 2x plus 3 whole power 1 by 3, right? That means you are calling this as some phi of x and this is x, right? So you are writing a function as x is equal to phi of x. Okay, this is one example. This is another example. We can see as 2x minus log to the base 10 x minus 9. Okay, so this is a function. So what we will do, okay, this is a function f of x is equal to 2x minus log x 10 log to the base 10 of x minus 9. So we will be writing this function as this is equal to 0. That means 2x minus log to the base 10, 2x is equal to log to the base 10 of x plus 9, which implies x is equal to log to the base 10 of x plus 9 by 2. So we will rewrite the function like this. You can see that this is nothing but x is equal to phi of x form. This is in the form x is equal to phi of x. And also for this function you have seen how to write x in the form of x is equal to phi of x. Okay, now we will see an example. Okay, now example solve 2x minus log to the base 10 of x minus 9 using successive approximation technique. Okay, now you can see this we are going to solve by using successive approximation technique. So you can see here 2x minus log to the base 10x minus 9 equal to 0. So we will find x from this. So x is equal to log to the base 10 x plus 9 by 2, right? So you can use this formula, or you can write log to the base 10x is equal to minus 2x plus 9. So x is equal to 10 power minus 2x plus 9. This is also possible, but anyway I am not going to use this. So this is my formula, right? Now with this I will be finding out the solution. So first of all, in order to understand what is the solution, in order to identify what is the solution, I will first find f of some interval. I will take, for example, I take the interval 4 and 5. That means f of 4 I will find. If I find f of 4 in this equation, if I find f of 4, then you will be getting it as minus 1.60206, and f of 5 I can get it as 0.30103. Okay, now the initial solution, so since you can see this is a less number, even though it is negative, so this is a positive number, so we will take the smaller value, that means a smaller number. That means we will consider initial solution x0 is equal to 4. So we will find x1. How to find x1? We will use this equation, for example equation 1. So x1 is equal to log to the base 10 of x0 plus 9 over 2. That means log to the base 10 of 4, then plus 9 divided by 2. You will get the solution as 4.80103. Now we will find x2. What is x2? x2 is, we will use our new x1 here, right? Then plus 9 over 2. So you know x1 is something log to the base 10. This is 4.80103 plus 9 over 2. So that is nothing but 4.84067. Like this we will find x3. For finding x3 we will use x2. So this is the equation. Similarly we continue. Okay, we will continue like this. So this procedure we continue. So this procedure will be continued and we will be finally getting the solution. Okay, so for example, if we are going to find, you can see in this example itself, you can see here we will be getting x3, we will be getting it as x3 will be 4.84245 and x4 is 4.84253 and x5 4.84253 254. So you can see that the solution is accurate for 3 decimal places, right? Is accurate for 3 decimal places. So this is the solution. So if I am asking for 3 decimal places, you can stop here, and anyway I will not be asking for the exam, and you can continue like this. So this method is known as the successive approximation technique. Now let us consider another example. F of x is equal to cosine of x minus 3x plus 5. Okay, so we will be finding the x. Okay, so it's very easy to, instead of finding the cosine inverse, you can find the x from this equation in two different way. You can equate cos x, that is cosine x is equal to 3x minus 5. You can write, or else you can write like this: cosine x minus 3x plus 5 equal to 0. So 3x is equal to cosine x plus 5, right? So x is equal to cosine x plus 5 over 3, and you can proceed like this. Okay, and in order to find the initial solution, you can put f of 0. If you put f of 0, you will be getting a number which is equal to 5, and f of 1 you will be getting it as minus 3 pi by 2 plus 5. Okay, minus 3 pi by 2 plus 5. So you can start with 0 or you can start with 1. Anyway, you can start with 0, for example. So you start with this value, then proceed, then you finally you will be getting the answer. So this method is known as successive approximation technique. Okay, so I hope that this is clear, right?